Let's take a look at solving systems of equations. The problems we do in this lesson are going to be primarily for systems of equations with two variables. So we're going to look at three different strategies. The first one being solving by graphing. To begin graphing these, remember that we are going to use the y equals mx plus b format. So we want to try to get our equations to look like y equals mx plus b. So I'm going to take the first one and I'm going to subtract 2x from both sides. Now, when I do that, I want you to notice that the 2x minus 2x cancels, leaving me with negative y equals. I like my x's to come first because the mx comes first. So I'm going to write this as negative 2x plus 1. Now, I've got to get the negative off of the y, so I'm going to divide each term by negative 1 here. And that leaves me with y equals 2x minus 1. Now remember, now that we have it in the y equals mx plus b form, we can pick out the slope and the y-intercept. The slope is right here in front of the x, and the y-intercept is being added or subtracted. So I know that the slope is 2, and I know that the y-intercept here is negative 1. That means on my graph, I'm going to begin at a y-intercept of negative 1. From there, I'm going to go up to and write 1 because I'm thinking of that slope as a fraction. So I'm going up to and write 1. Do it again so that you can get a really nice solid line. 1, 2, and then over 1. You can do it as many times as you like. What I like about it is that it brings us to a place where I can take my straight edge, forgive my nice little Amazon gift card there, but it becomes a nice straight edge that I can line up. And when I have more than 2 points, it's a little bit easier to line up your straight edge there. Okay. I know some students who just up 2 over 1, up 2 over 1, all the way off the graph. You're welcome to do that too. You'll definitely get a really nice graph. Okay, now that I've got one line graph, let's do the same with the other. So I'm going to get this into y equals mx plus b form. Let me subtract the 6x. That leaves me with negative 3y. Remember, I like to write my x's first. Negative 6x plus 3. Then I'm going to divide every term by negative 3, same way I did divided by negative 1 on the previous equation. That leaves me with y equals 2x minus 1. I'm getting the same equation. So essentially, I'm going to graph the same line, right? I'm going to graph the exact same line here. So when we solve by graphing, we're looking for where the lines intersect. Ask yourself, where do these two lines intersect? Well, everywhere, right? Well, how do we say everywhere in a technical math answer? Well, what we say is that there are infinitely many solutions. So I want to make a distinction here. Notice I didn't say all solutions and I didn't say all real numbers because these lines don't intersect at this point. They just intersect at every point on this line, and there are an infinite number of points on this line. So we want to be really careful. Kind of put that in your notes so you know how to answer that if the two lines end up in the same place, then we're going to answer infinitely many solutions. Let's add one more note to your notes here because you're going to have some in the assignment for this lesson. So if the lines are parallel, and I'm going to draw a little sketch of a set of parallel lines here, right? because you and I know that parallel lines don't touch, I'm just going to draw a picture of what that looks like, then we would say there is no solution. Okay, so I want that in your notes so you know for next time. Okay, let's turn our attention then to the other two techniques. So the next technique is to solve by substitution. So this is where I'm going to take one of the equations, and it doesn't matter which one, and I'm going to solve for a single variable. When I look at these two equations, though, this first equation looks easier to solve for x because the x doesn't have a number in front of it. So you could technically do either one, but I want you to work smarter, not harder. So I want you to take the equation that has a variable by itself with no number in front of it, because that's going to be easier for you. Okay, let's get this x by itself. We have to move the minus 2y. The way we do that is to add 2y to both sides. I said earlier that I like my variables to come first. So when I write this, I write x equals, notice my minus 2y plus 2y cancel, and I write it as 2y plus 5. Now, what am I going to do with that? Well, I'm going to put 2y plus 5 into the second equation for x. Let me show you how I do that. I'm going to take 4, and I'm going to create some space, just like that. Because see, what I'm going to do is I'm going to drop that 2y plus 5 into that parentheses. Now, you may be asking yourself, why would you put parentheses around it? Because look at where the 4 is. What am I going to have to do with that 4 there? Yes, I'm going to distribute. So let's distribute. 4 times 2y gives me 8y. 4 times 5 gives me 20. And now we have an equation we can solve, right? Let's combine our like terms. 8y plus 3y equals 11y. And now we can subtract 20, just like we've done before with solving our equations. I've got 11y equals negative 11, so y equals negative 1. Now, we have found half of the solution, right? We found y, but notice we still don't know what x is. So this is where you're going to do another substitution. You can choose either equation. It doesn't matter which one you choose. I'm going to choose that first one, and I'm going to substitute negative 1 for y. So that gives me x minus negative 2. Now, minus a negative, you know we can write that as plus a positive. And so x is 3. Now we have the whole answer, right? We have x and y. We're going to write that as an ordered pair as my solution for this one. Now, graphing method, substitution, both should yield the same answer, okay? They're just a different method to be able to solve. Let's look at one more method for solving the systems of equations, and that is elimination. Now, in elimination, you're looking to eliminate a variable. And the way that we eliminate a variable is we want the same number in front of the variable, but we want one to be positive and one to be negative. I'm going to show you why here in just an example in just a second. So I'm going to try to eliminate the x's. Since I already have a 12 here, I'm going to need a negative 12 here. Remember, I want them to have the same number, one to be positive, one to be negative. So the way to get a negative 12 here is to multiply the second equation by -4. Now, just for my note's sake, I write it like this so I can kind of keep track of what I'm doing in the problem. So there's the original problem. Now, what I'm going to do is I'm just going to draw an arrow here to show I didn't do anything to that first equation. And then the second equation, I'm going to multiply by -4. So I just for my note's sake, that's how I write. I just show that, hey, I'm fixing to rewrite this. And what I did is multiply by -4. So let's multiply each of the terms in the second equation by -4. So 3x times -4 is -12x. 4y times -4 gives me -16y. And 2 times -4 gives me -8. So I multiplied every term in that second equation by -4. And now what I'm going to do is add these two equations together. Now my 12x and my -12x are going to cancel. We did that on purpose, right, to eliminate the x's. Then I've got 8y minus 16y. That'll give me -8y equals -16. Well, that's a pretty easy equation. I can divide both sides by -8, and I get that y equals 2. Now, just like before, that's only 1/2 of my solution. I still have to go find x. And we're not going to get around any substitution here. So just like before, you're going to choose one of the equations. It doesn't matter which one you choose. The second one looks a little bit simpler simply because it's got smaller numbers. So I might choose that. Remember, work smarter, not harder. So I've got 3x plus 4y equals 2. We're going to put in 2 for y. And we solve. So I've got 3x plus 8 equals 2. Then we can subtract 8 on both sides. And that leaves me with 3x equals -6, so that x equals -2. Again, just like before, write your answer as an ordered pair. Think of them in alphabetical order, so x and then y. Even if the variables being used are A and B or M and N, they are always written in numerical order. So I hope that helps you with your lesson here. Good luck on the assignment. And let me know in the comments here if you wanted to see any more examples or anything I can clarify there. Bye for now.